This is a case study in how we redid all of our infrastructure tooling. The tagline, rewrites are bad, right? So who am I? I'm the CTO of Fairwinds. We build, run, and maintain Kubernetes infrastructure for other people. We've got some open source projects that are popular in the Kubernetes space. We're also very active in the CNCF. So if you're familiar with that community, you may see me around. But more importantly, I've been around in the infrastructure world for a little bit. I got my start building networks to play StarCraft with my dad in my house as a kid. And it just never stopped from there. And I've always just been a huge fan of infrastructure. There's some contact info in there I could share later if anybody wants to talk. But at Fairwinds, like I said, we build, run, and maintain Kubernetes infrastructure for other people, allowing them to focus on their business critical applications rather than the toil of running Kubernetes in their core infrastructure. So what this means is we solve a very specific set of problems for our customers, and we have some semi-unique problems, but I think they transfer to a lot of other companies as well. So we operate dozens, if not hundreds of clusters. We're hoping to scale that more over time. We run across 3 separate cloud providers. We run across the big 3 right now for now, but we could be adding more of those in the future. So we're always cognizant of that. Every single one of those clusters is in its own account, project, subscription, or organizational structure because it's all of our customers' infrastructure we build inside of their cloud. And so we don't necessarily have control over every piece of the overlying account. So that does introduce some interesting questions sometimes. We also have a contractual obligation to be able to let our customers leave. This is something that's been good for us as a business. We like them to be able to take their infrastructure as code and we'll leave when they're done so that they're not locked in with us. So that is a semi-unique challenge to how we run our business. Authentication is interesting. This kind of goes back to the third point there. Everybody has their own way of running their cloud accounts. And so we have to be able to integrate with all of those. And again, not all of these are unique to us. If you look at a large company, like we heard earlier from Harness, I think a lot of these problems are similar, if not exactly the same as what they're running it. Oh, cool. So again, this is a case study. We wanted to rethink how we managed all of this infrastructure. We had a lot of internal tooling that we weren't necessarily happy about. And so what I want to talk about today is really not so much the exact how we did that, although I'm going to talk about that. What I want to talk about is the way that we thought about it, the way we went about it, the questions we asked ourselves, the process that we used to get through this process in order to have a successful outcome rather than just throwing stuff at the wall to see what sticks. So why would we do this? Sounds like a terrible idea. Rewrites are bad. That's like the thing that you learn if you go to talks like this. And so there's a lot of bad reasons to do rewrites. There's reasons that people do rewrites. They like shiny things. I'm an engineer as well. I have been an engineer. I love shiny stuff. I run Kubernetes for crying out loud. 8 years ago, that was the shiny thing that everybody wanted to run. So I understand it, but it's not a reason to rewrite your entire stack. Similarly, because one guy told you to, also not a good reason to do it. Good reasons, I think there's really only one good reason, and it's business outcomes. Some possible business outcomes, maybe you need to get features to market faster. You need to be able to make changes faster because that's what makes your customers happy. That's a business outcome, not a technological outcome. There's tech in the middle of that, but there's business leading up to it. Same with agility and security. We do security because we don't want to get breached and we don't want to get sued by our customers, or we don't want to face fines because we're in a regulatory environment. That's really why we actually do security. I don't like that, but it is the reality that we live with. So if I didn't mention it, business reasons are the reasons to do a rewrite. And again, there's tech in the middle of that, but you have to be able to tie that back to a business outcome too. So for us, what we found was that we couldn't make changes across all of that customer infrastructure fast enough. We had a process that had too many manual steps. It had too many kind of checkpoints built into it, and it was slowing down our ability to keep our customer infrastructure updated. Most of what we do is updates. We do the boring stuff. We upgrade your add-ons. We upgrade your clusters. They respond to CVEs and triage them. It's the things that really nobody else wants to do. And we have to be able to do that quickly because the Kubernetes environment moves really fast. We releases 3 times a year. Every add-on is releasing daily, weekly, monthly. We upgrade them all monthly in order to keep on top of it. And so we have to be able to make a single change across every single customer very quickly. And we couldn't do that. And then second, we were accumulating a lot of tech debt in our tooling stack. We had a system that had been built 9 years ago. It had been loosely worked on here and there, and we were accumulating that at a rate that we couldn't really pay it down. All right. So what process did we use? How did we go about doing this? So the first thing we did is we sat down and we really thought about what our current solution was. We actually detailed out what is it that it does and how does it work? Because sometimes when you've had something as long as we had our current solution, you don't really know how it works or why it was designed, and you don't necessarily know all of the assumptions that went into making it. So we sat down and thought about those and wrote those down. Then we identified the problems that we had. I talked about some of them already. We listed out the requirements for our new solution. We thought about all the possible ways we could solve it. I'm going to go into more detail about all these, so I'll go quickly here. Then there's the picking. Very questionable there. We did many different POCs, but not as many as we might have liked. I'll talk about that as well. We iterated on those solutions, and then eventually we implemented it. And today we're probably at about 75, 80% implementation of this new solution. So what was our existing solution? It was a Python-based templating engine that would spit out infrastructure as code into an individual infrastructure as code repository for every customer. But it was built, again, 8 years ago, 9 years ago now. And at the time, all of our engineers were a little bit scared of automation. They were afraid to click that button and let something roll out across every customer. A lot of our customers were very bespoke. Everything was built individually for them. That's still the case, but we've actually enabled that in the tooling. When it was built, we were afraid of that. And you had to do this step where you basically logged into a customer's infrastructure. You ran a shell command, got into their infrastructure, and then you could interact with the tooling to make changes, but it was very interactive, which, as you can imagine, as you start to get to dozens, hundreds of customers, that becomes extremely slow. So again, I already talked about the issues a little bit, but if we outline them specifically, we couldn't do rapid changes. We required this interactive step. So this is also a security problem. We weren't able to separate concerns. Every single engineer had to be able to log into the customer infrastructure as well as make changes. Now we can do everything through a Git-based approach. We wanted to separate those two things so they don't need access to the infrastructure to propose or make a change to it. One of the big things that we ran into was the team skill set. Kubernetes is written in Go. All of our open source is written in Go. All of our internal software is written in Go. We had this one Python project left across the entire company, and nobody knew Python anymore. I was like the only person at the company who could work on the tooling because I was the only one who knew how it was built. And so with those skills degrading across the team, we had two options. It was either rewrite and so that people continue to work on it, or upskill the team in a language that they don't necessarily really need to be experts in going forward. Because of that, there was very little participation in upgrading and working on the tooling. And from that, what happened was all of our infrastructure as code fell out of tooling management, which was hand managed everywhere. And that led to drift across our customers. And we started seeing errors in different customers where people would make a mistake. So nothing earth shattering here, but it was really important for us to sit down and talk through this and understand as a team, what are the problems we have, and then start working on what we're going to do to fix it. So we definitely wanted to keep Git as our source of truth. We had to have, again, this contractual obligation to either have a separate repository for every customer or be able to export their infrastructure as code in some way. That was a business requirement that we had to fulfill, and so we couldn't get rid of it. We decided that one of the more important things about migrating this tooling stack was to not have any impact on the customer. We could have done it in a way that we said, we're going to rebuild all your infrastructure and we're going to migrate you to this new infrastructure, but that would have been largely impacting to our customers. And so it had to be somewhat silent to the customer. And we need to be able to avoid the drift that we were seeing across the customers. Now, this could be as simple as just running the infrastructure as code more often or ensuring that everything was under infrastructure as code control. It doesn't have to be sophisticated drift detection. We needed to be able to do it somehow. And then again, that first thing that we talked about, we need to be able to make sweeping changes across all of our infrastructure all at once so that we could meet our business requirements. But we could still have manual steps in here, reviews, approvals, those are important as well. And then removing that interactivity piece so that we could tighten up security and separate concerns where it was appropriate. All right. So then the next thing we did, this isn't necessarily required as part of this process, but I thought it was valuable for the team. We wrote down a goal statement around this. We took those requirements and distilled them into a thing that we could all gather around and see as a team. And so that became the guiding light for the further discussions where we started brainstorming solutions. And I'm not going to read that. You can all read. Don't read this. This is just an example. This is the living Excalibur document that became our brainstorming. And this went through probably 10,000 iterations. I love to be able to just write on a whiteboard with a group and move the text around. And so this is where we did all of our brainstorming. So we put at the top the goal statement, put our requirements on it. And then this went through, like I said, 1,000 iterations. But the key here was not what's on this page, but the process, how we got here. And so we really sat down and said, okay, what if we started from scratch? What would we do? And that's how we started the brainstorming. We started writing down solutions, a bunch of tools went up on there, a bunch of concepts went on there. And what happened was it shook out into 3 conceptual ways in which we could organize our tool. And so the names of the tools and whatnot are not important here, and I'll go through each of the different types. But really, we focused on concepts and architectural patterns rather than focusing on tools, which allowed us to separate those decisions and decide on a pattern before we chose a tool. I think that's super important. So the first possible solution was to double down on what we were doing or create the next iteration of what we were already doing, which is templating out infrastructure as code repositories for each individual customer. And then we went through each of these changes, each of these concepts, and wrote down pros and cons. So for this one, it's relatively easy to make changes on everybody's infrastructure as code. Making changes is centralized. We still had that ability to just have a separate infrastructure as code repository for every customer. You could still do rapid overrides for an individual customer. So because each customer has their own repository, you can go make a change to that repository in an on-call situation or during an incident if you need to rapidly fix something, still going through the approval process for that individual repository, but not needing to necessarily codify it into the tooling. And then you could go back and forth that later as future went on. So that's one benefit of doing it this way. It separates the blast radius for every customer out into their own repository. And this pattern was familiar to us. The team was very comfortable with this. It's similar to what we were doing. So that's a pro as we go forward. The team doesn't have to learn a whole new thing. One of the cons, if we stuck with the Python version, obviously, that was going to be a problem. That kind of middle layer where we're having essentially 2 layers of infrastructure as code is a little bit clunky. And then if we didn't really fully automate this solution, we were just going to end up back where we were. And so that was definitely a con here. We needed to be careful with that. So the second possible pattern that we were talking about was to centralize all the infrastructure as code and have it just act on the customer infrastructure directly. This is more what you would see inside of a single company, not running a managed service business, where you would have just either a monolith or lots of infrastructure as code repositories internally that manage directly the customer infrastructure. So this is removing that templating layer and just pulling all the templates into a single code repository. So some pros and cons of this one. I was going to have a clicker, so sorry about that. All the changes are made in one place. There's not this second layer. It's a little bit simpler. One thing that we wanted to consider as a side benefit that kept in the back of our heads was creating new ephemeral clusters for testing more quickly. But that wasn't one of our primary goals. It was a nice to have. And so it's really in a pro column, but it's not something that we made a requirement project. You have higher risk here. With great automation comes the ability to break things faster. So if everything was centralized directly with no middle step in between, the risk goes up. The question of how to transfer infrastructure as code to customers when they leave is a little bit messier, depending on how you structure that centralized repository. Because we manage 3 different cloud providers, we have a lot of code in there that doesn't necessarily apply to each and every customer. And then centralizing all of the access into all the repositories rather than keep it into all the customers, rather than keeping separate, introduce potential risks. And the question of how to import their existing infrastructure into the new tooling stack became more complicated than if we doubled down on our original one. Then the last one was to really turn the whole thing on its head and just change how we operated entirely. Switch to something like Rancher, Crossplane, Garden, something using Cluster API, write our own thing using Cluster API. I don't know. There's a lot of different options in this paradigm, but this was really a huge change from the way we'd done things in the past. And again, pros and cons to this. It's Kubernetes native, super familiar. They're probably not, if we're not writing it ourselves, there's no code involved, so I don't have to teach all my folks how to write controllers. But then we have more internal infrastructure to maintain. We've got a whole new third-party application with its own level of complication and sophistication. If you're familiar with Crossplane, it's not a simple project. It's not the easiest thing in the world to run. And the question of importing was still a question mark. And also the transfer of infrastructure as code to our customers, basically non-existent in this environment. After we ran through all those possible solutions, all the pros and cons, weighing them with business implications, we were leaning towards one. We had picked one, but this is where in the process, you have a lot of options. And it depends on how big your team is, how much space you have for doing R&D and things like that. So we have a small team. Our R&D department is nobody. It's a quarter of my time and somebody else's. And so we didn't have time to go build a full POC of every single one of these solutions. But if you have the time, you have the luxury of that, do it. But when you're doing proofs of concept of either tools or individual paradigms, I think there's a few rules that are easy to follow. Time box them, because otherwise they will run forever. Keep them at just the right amount of scope. And this is a little bit of art in that you want to get just deep enough into the proof of concept to run into the rough edges that might be a breaking or blocking issue for that paradigm. But you also don't want to spend so much time building out every single piece of functionality that's not a proof of concept anymore. You've actually just built the whole solution. And so I think that takes a little bit of finagling and process to get the right amount of proof of concept going. So we really landed on that first solution, which was the one that was familiar to us. And the reason we landed there is because it was the lowest lift for us to implement across all of our customers, and it really fit the team's skill set. So we ended up building it in Terraform. And so our team all very familiar with Terraform. So it's a lot of Terraform now. And there's no additional languages. We looked at tools like Pulumi and other things like that. I love Pulumi, but getting the whole team skilled up on a programming language that we settled on in order to use something like Pulumi meant that we just didn't have the time to spend on that. So I think a piece of the iteration here, you've picked your paradigm, you now need to pick tools, and you need to think about the cost of implementing that tool, not just in the implementation time, but upskilling your team if you need it and getting through potential issues. So you're going to have to iterate a lot. The solution that we picked looks a little bit like what was on that first section of the slide, but it's actually changed quite a bit since then because you run into problems and you have to fix it. So iteration is always important. Yeah. Keep iterating and then do the implementation. So by doing this process the way we did it, that brainstorming phase, the entire team was involved. We took that brainstorming phase, we wrote it into a design document. The entire team was involved in that as well. Everyone had a chance to comment on it and come up with different ideas on how to solve it. So by the time we got to the point where we were actually implementing it, because we spent so much time in the design phase, the POC phase, choosing all these solutions, everybody was already bought in. And so by this time now, about a year and a half, a year later, every single member of the team has a hand in working on this new solution. They're all committing code to it. They're all working on it. And so getting that team all together bought in different ways, whether it's reviewing RFPs or it's writing a design doc and having people comment on it or involving everyone in the brainstorming process is super important. We did all that work up front. It should have been easy to implement, right? No, that's not true. Like I said, we're about 80% of the way through. It's going very well. The whole team is involved in the process. They're excited about it, but of course, other things come up and they stall your implementation. So just be ready for that. Nothing ever goes as quick as you want it to, especially when it's a full rewrite of your whole tool stack. So some tips as you go through this process, if you're thinking about re-architecting your tooling stack or doing something similar to this, I alluded to this earlier, but don't pick tools. Tools are not solutions. Tools are ways to solve problems in your solution. So think about conceptually, how am I architecting this overall solution, and then find the tools that fit that paradigm. Now, it's a little bit circular because sometimes the tools inform the paradigm, but don't focus so much on the tool. We actually ran into a really fun problem in the middle of this. We were designing this and evaluating tools for running Terraform right as HashiCorp changed the licensing on Terraform. Like the week we decided to go with Terraform, they did this. And so we're sitting there going, okay, now we have new business problems and new business risks, which are, and we didn't even exist yet. It was about to. We didn't know where it was going to go. So, but by sticking to the concept of running Terraform, we were able to shift to something else to run Terraform that wasn't at risk at the time. I think by not settling on a specific tool, you can mitigate some of that risk up front. Don't do these designs aspirationally. We really want to, right? Like I really wanted to come in and be like, all right, we're writing this really cool Pulumi stack and it's going to go fix all of our problems. And I'm going to teach everybody how to write Go and they're all going to be amazing Go developers. It's just not realistic, right? I don't have the resources to do that with them. So be realistic about your designs. Some of this is new to us and it's cool and people are learning things, but you have to measure that and use it carefully and not just go straight for the top, what you want to do. And in that same vein, keep things simple. The stack we came up with is not complicated. It's a templating engine written in Terraform that spits out more infrastructure as code. Like it's not a sexy solution. But it works and it's simple and the team likes it and it fulfills its purpose. So don't be afraid to use boring technologies and keep things simple. And then I've said this multiple times, but be mindful of what your team can and cannot do and factor in the budget or the time to upskill folks and teach them new skills if that's part of your solution. So that's all I've got. Anybody have any questions?